All right, let's dive right into this. Welcome to the Explainer. Today, we're exploring a massive, literally industry-defining paradigm shift, moving away from traditional batch processing over to continuous, stateful streaming logic. If your team has been relying on scheduled cron jobs to get things done, well, buckle up. We're going to see if there's a faster, much more resilient way to handle your data.
Here is our quick roadmap for today. We'll start with a great architectural shift, move into dual-velocity data routing, look at continuous market data logic, tackle parsing heavy SEC filings, and wrap up with some crucial migration gotchas to watch. We're going to cover both the theoretical mindset shift and the practical coding translations so you're fully equipped for this migration.
So let's kick things off with Section 1, the Great Architectural Shift. It's time to fundamentally change how we think about system data. Now be honest with yourself for a second. Are you still thinking in batches? We get so incredibly used to transient task routing, right? You fire off the message, it sits there, and you just leave the actual heavy lifting to some scheduled hourly cron job. But what if your data didn't have to wait around? What if it could be processed the exact millisecond it arrives?
Now, what's really interesting about this slide is the stark contrast between these two worlds. In an old RabbitMQ setup, you had destructive reads. Basically, once a worker reads a message, poof, it's gone forever. It's a fire-and-forget system. You also relied heavily on stateless workers constantly checking in with central databases like Postgres or Redis on a schedule. But look over at the Kafka and Quix Streams side. Kafka actually acts as a persistent database of continuous events. The messages just stay there. Multiple different services can read the exact same data entirely independently. And instead of stateless workers, Quix uses stateful streams, storing things locally right there using RocksDB. We're talking continuous processing, event by event, with unbelievably low latency.
Moving right along to Section 2, dual-velocity data routing.
When you build out this new architecture, you have to handle two completely contrasting data speeds. And that means splitting them into dedicated topics to avoid lag. On the top row, we've got real-time market data. This is super high throughput, incredibly low latency. You absolutely have to partition this by the stock ticker, like AAPL or MST. Why? Because that guarantees all the ticks for a specific asset arrive at the exact same worker in strict chronological order. It's absolutely essential for accurate order books. Plus, you only need low retention here, maybe keep it a few days before dropping into a time series database. But look at the second row. SEC filings are the exact opposite, low throughput, but they demand massive compute power. We partition these by CIK or company ID. And crucially, we set the retention here to infinite. These are historical compliance events. If you ever want to update your AI embedding strategy down the line, you want to be able to replay this entire topic from the beginning of time.
Okay, Section 3, Continuous Market Data Logic. Let's move from the routing theory into the practical reality.
To actually process high-speed market data natively in memory, without relying on those 5-minute cron jobs, we need to understand a vital concept, the tumbling window. A tumbling window is a native Quix Streams mechanism. It automatically manages your in-memory state over a specific, defined time block, let's say 60 seconds. So instead of constantly writing to and querying from a central database just to figure out what happened in the last minute, Quix holds that 60-second window natively in memory, calculates your metrics on the fly, and then simply tumbles forward to the next minute.
So the crucial point is how this transforms your actual day-to-day coding. If you want to calculate a volume-weighted average price, or VWAP, you don't need a batch script waking up every 5 minutes anymore. Within that tumbling window we just talked about, Quix automatically tracks the state. You just sum up the total volume and the total value across those ticks in real time. You divide total value by total volume, and boom, you have your VWAP calculated on the fly, completely natively, with zero central database bottleneck. It's brilliant.
Next up, Section 4, parsing heavy SEC filings. Time to shift to the other end of the velocity spectrum.
And this brilliantly illustrates how we replace stateless RabbitMQ worker pools to process really complex documents. If market data is a fire hose of tiny drops, SEC filings are like giant boulders being dropped into your stream. We use a really concrete linear pipeline to structure this raw text for things like LLM vector databases. Step 1 is the ingest service. It simply pulls Edgar and dumps the massive raw text chunk directly into a raw Kafka topic. Easy. Step 2 is where Quix comes in. The parsing service consumes that raw text, uses libraries like Beautiful Soup or regex to extract highly specific sections like Item 1A, risk factors, and publishes that newly structured data to a new topic. Finally, Step 3. A downstream consumer grabs that text, generates vector embeddings, and pushes them straight into your database. It's clean,
It's isolated and it works perfectly. Now, this represents a massive win for your system's reliability. In this pipeline, Kafka acts as a literal shock absorber. If you were using an old batch script and your downstream vector database crashed mid-execution, you'd probably lose filings, or at best have to manually untangle a huge mess. But with Kafka, it just catches to back pressure. Even if your vector DB goes offline for hours, Kafka just patiently holds on to those structured filings. It absolutely guarantees no filings are lost. Once the DB is back online, the pipeline just picks up and resumes right where it left off.
Finally, Section 5. Migration gotchas to watch. Consider this your survival guide. Because, every architectural shift comes with hidden traps. And the first major one is what we call the poison pill problem. Imagine a terribly formatted, completely corrupt SEC filing entering your stream. It's a really aggressive obstacle. Your worker tries to parse it, fails, and crashes. But because Kafka is so incredibly reliable, when the worker reboots, Kafka stubbornly says, "Hey, you didn't finish this message. Here it is again." And the worker crashes again, over and over. Kafka will literally force-feed this bad message into a continuous crash loop until you step in and intervene. So how do we actually survive this and other gotchas? Let's rapid-fire through these critical survival tips. Number 1, fix that poison pill by wrapping your Quix processing loops in robust try/except blocks. When a message inevitably fails, route it to a dead letter queue, or DLQ, so the rest of the pipeline can just keep moving. Number 2, watch your state size. If you're tracking massive order books across thousands of tickers inside Quix, it uses local RocksDB. Monitor your local disk space, because it will fill up fast. And number 3, listen, this one is absolutely crucial. Beware of consumer group rebalances. If your heavy LLM API or complex regex parsing takes too long, Kafka will just assume your worker died and trigger a massively disruptive rebalance. You must keep your processing times well below Kafka's configured max.poll.interval.ms. If a task is too heavy, you've got to handle it asynchronously.
So we've covered the mindset shift, the routing, the stateful logic, and the survival gotchas. It is an incredible journey moving from RabbitMQ over to Kafka and Quix Streams. But as we wrap up this explainer, I want to leave you with one final strategic architectural question to ponder for your own team. Are you planning to deploy all of this powerful new infrastructure on premises, taking on all that management yourself? Or are you looking to utilize managed services like Confluent Cloud or Quix Cloud to ease the transition? There's definitely no wrong answer, but it's for sure the next big decision you have to make. Thanks so much for joining me today, and happy streaming.